Monomial. Have you heard it before?
No.
That prefix, mono. What number is that? What? 1. Okay. So a monomial is a, like one number, a variable, or a product of a number and variable. But it's just one term is how I like to think of it. It's just one term. Okay. And we're going to work with monomials in terms of adding, subtracting, multiplying, dividing them all week into next week. Okay. So when I'm talking about a monomial, it could be one number like 15. It can be a variable like y, or it could be something like -1/2 x squared y cubed, or it could be something like 14 z to the 4th. Okay, but it's one term. Okay. Now, if we have terms where we have the same variable and the same exponent, then we consider those to be like terms. And we want to combine like terms. Okay, so if we're adding or subtracting monomials like you see in these problems down here, all I'm asking you to do is combine like terms. Okay. So this example number 1, 17x minus 25x. Do those have the same variable? Yeah, then we can take 17 minus 25 to get -8, and this is -8x. Number 2, do we have like terms? Yeah, we have y squared. So -23y squared plus 6y squared would be 17y squared. Now, what if there's more than one letter? Oh no. Make sure the letters match. So do you see how this is a cubed BC? We can only combine it with another term that has a cubed BC. If it was a squared BC, those are not the same. The exponents have to match also. So -15 a cubed BC plus 6 a cubed BC, those are like terms. This would add together to be -9 a cubed BC. Nice. Okay, now what about this one? Do we have like terms? Yeah. X squared y, x squared y. But what's that second coefficient? The second coefficient. Ah, this is a 1. So this is 37 x squared y. Yeah. Do 6 and 8. You and your elbow partner work on 6 and 8. All right, Avery, what did you and Maddie get for number 6? OP? And then OP, QRS. Okay, humor's not there. All right, 1 MN, do you agree?
Yes.
Do you have to write the 1?
No.
You do not have to write the 1. You can write MN or you can write 1 MN. Both mean the same thing.
Wow.
Okay, I know. Okay. All right, Andrew, what did you get for 8? We agree here?
Yeah.
Incredible. Who said no? You don't agree? Okay, what did you get? Okay, so if we have negative 25 minus 25, so we're already negative. Minus 25 means we're gonna go more negative. So if this were a positive, I agree it would be 0. Kane. We'll go and stop. If this were a positive and that one was negative, it would be 0. Does that make sense? Okay. All right, now let's look at the next couple examples. So what do you notice about like number 10 right below it?
There's a lot more. There's 3.
Okay, there's 3 terms. Are they all alike? No. We have B's and we have A's. So we can say 8A plus 2B. Okay. Ooh, this number 12 is tricky. Are those all the same? Are those all like terms? Okay, what matches this first term? Which one would we combine with it? The third term? And you're telling me that the second one is different. Preston, why?
Because the M is not squared.
Okay, notice how the square is with the M and N has just an exponent of 1. But here, M has the exponent of 1 and N is squared. So we end up with 9 M squared N plus 7 and N squared. Okay, so this is what I want you to do. I want you to do number 11 and I want you to do number 15. Check in with your elbow partner, please. So 11 and 15. Colin, what did you get for number 11?
got 17 W squared. What? Sorry, minus 22 W.
Do you agree with Colin?
Yeah.
You guess? Okay. Now, Gavin, in number 15, I'm asking you to subtract 9A from negative 15A. How do we set that up? We are subtracting 9A from negative 15A. So we have to write it as negative 15A minus 9A. Do you understand why that is? Somebody's phone needs to be shut off. So this is negative 24. Okie dokie. We went from like super excited to like pretty. Oh, I think there is. All right, next page. Okay, so I want you to look at this right here. I'm telling you that x squared times x cubed is x to the 5th. And I'm telling you that a to the 9th times a to the 1st, right? If there's not an exponent, we assume it's 1, is a to the 10th. Have a conversation with your elbow partner about what you think the answer to number 19 is and why.
Oh, I'm on the wrong. I'm really worried.
We're not.
All right, eyes up here. Who thinks they have a pretty confident assumption? Sophia. W to the 11th. Okay. And how did you get that? How did you get 11?
You copied what you did for number 17.
Well, what did I do?
You added.
Okay. So in all of these ones, I added the exponents. Let's talk about why. When we are multiplying two terms that have the same base, then we are going to add their exponents. Please write that in. When we're multiplying exponentials that have the same base, we are going to add their exponents. Okay, so x squared times x cubed was x to the 5th. We added 2 and 3 together. A to the 9th times a to the 1st gave us a to the 10th. We added 9 and 1 together. Okay. Well, now let's look what happens when we have coefficients. It's going to be okay. All right, so, okay, let's zoom in just to number 20. Okay. Let's focus on the coefficients. Do you see how this is multiplication? Tough question here, Nirvan. What's 4 times 3?
12.
12. So we can take 4 times 3 to get 12. Then if we're going to take x squared times x to the 5th, it would become x to the what? It would become x to the 7th because we would need to add the exponents. When we're multiplying, we add the exponents. Is that okay?
Yes.
You good with that? Okay. Write down what you just think this answer is going to be. Just write down what you think. Okay, what's 3 times 5? Did you write down 15?
Yes.
That's good. Then if we're multiplying x to the 6th times x squared, we are going to add those exponents together. This example, we're going to multiply 5 and 6. When we multiply x squared and x to the 4th, we get x to the 6th power. Okay. You and your elbow partner work together on 23 and 24. See what you can do for us.
So we can spell words with math.
Kind of, yeah.
Is that no on this? That's a,
Hello.
that's a six.
It is not. Okay, okay. No, I'm in the right place. Okay. Right here. How?
Oh, so six, because it's like a one.
Not my father.
I thought you were gonna give me the answer. Oh, it's 20. 7 times 4. 8. It's 20.
I got it. Sorry.
I want him to perk his head up.
You can get 28, 11. Wait, P 11. Is that a Q?
That is
Yeah.
Q.
A Q? Why can it be backward?
It's a Q. Reagan, what did you get for number 23? Okay, yeah. Okay, so we say A to the 5th, B to the 6th. Okay, Colin, explain to me how she got -12.
So -4 times 3 would equal -12.
Okay, Maddie, how'd she get A to the 5th? Okay, so we are multiplying, which means we add the exponents. I know that's not quite what you said, but I think it's what you meant, okay? Since we're multiplying, we add the exponent. Same with b to the 6th, b to the 1st times b to the 5th, we add our exponents, okay? Excellent. Seth, what'd you get for 24? Elliot, do you agree with this? Yes, okay. -7 times -4 gives us the 28. Since we're multiplying, we're gonna add the exponents. Okay, I'm gonna give you a little challenge here. What I would like you to do is drop your pencils. Okay. And I'm going to send you to one of the whiteboards to do this problem, okay? Notice how there's multiplication and addition. So I want you to talk through it with your group when you get to the whiteboard and then come up with an answer for me, okay? So you three grab an Excel marker and you're gonna be right here. You three, you're gonna be at this middle one. You three, you're gonna be right here. You two plus Nirvan, you're gonna go the purple. You remaining three, go to that back one.
So
Wait,
what-
you three go to the one first here.
Grab my eye.
I guess you use-
And then 4x.
It doesn't matter.
You won't give me number 2.
X is out.
Y.
Like this is 4.
Yep, and then 3x is the second. Okay, you saw this. Got it, guys. Wait. So what I do is like, yeah. Green Bay. You're Green Bay.
Oh, yeah. What? No.
If you are done with the problem, go back to your seat.
We got 58%.
No, wait. 58?
I got Abraham Lincoln. What about you guys? Yeah. Plus 3 I got that too. Oh my god. Did you get Abraham Lincoln? 8 plus 3 is 11, not 12. That's Amy's fault.
That's
Amy,
an
go.
8?
Oh my
Amy's
god.
on
Amy, what the heck? Amy, it's 11. Amy. Amy. It's 11. 8 plus 3. Amy. 8 plus 3 is 11. Hey, that was Sophia. I know, honey.
That was you.
I'm not ready to get scratched. Well, wait. I struggled. It's sad. This marker is cracked. It's cracked. Or what?
Right now. You won't. Every option.
Okay. Okay, I want you to look around. At the different answers. Are they matching?
Yeah.
I could do the 58%.
Not my fault.
Hey. Okay, I do not like what I'm hearing right now. I don't like the discouragement in your words. We encourage each other. We also make mistakes. So if somebody doesn't have the answer that you did, first of all, maybe you're wrong. Second of all, it's also okay to make a mistake because that is how we learn. So I see many different answers right now, not just 2 different answers. Okay. So let's talk through, like I see like this group over here. Okay. It looks like they have like 8 something something and 3 something something. So it looks like, what did you do first? Oh, we multiplied these 2 together. That's what it looks like, right? So if we multiply these 2 together, 2 times 4 is 8. X to the 5th times X, we add the exponents. y squared times y cubed, we add the exponents. Good. Plus, oh, you are paying attention. Amazing. Thank you. All right. Over here, we multiply 1 and 3. X to the 4th times x squared, y to the 4th times y to the 1st. What just happened?
It's replacing
Or what?
the exponents or whatever I was saying.
We have like terms, people. We have like terms. And we are adding. When we add, we're going to add the coefficients, but then the exponents have to stay the same. Okay? So how about I give you an opportunity to redeem yourself with your group, go back and do number 36.
Who's you?
Alright, so parentheses, 4a to the third, b to the fourth, other. You want to break it up? 5a, b to the second, no, other parentheses. Plus a to the second, b to the third.
Where are you getting the 4 from? No. Where?
Amy, what are you trying?
When you have an answer, you can head back to your table.
Sophia, do you want to look at 36? Are you helping your group?
Give moral support. Give moral support.
Right, okay.
No, there's just like nothing to it. When you're done. Okay.
Good job.
35. Yes. Nice to meet you.
Hey, bro.
Everything okay?
Yeah, oh, come on.
The text, you were looking at your phone for a text. Okay.
Oh,
I think I got it wrong again.
no.
I saw that, but you guys didn't want me to. Yeah, and then it would just be -1a, right?
Why'd you say it like it was a question?
Okay. 1 times -2.
Okay, I get it. All right, can we change it to 18?
Okay. There. Okay, I got you. Gotcha.
Was it not this time?
If you guys want to let me.
All right. Your answer should be this.
Did it.
Oh,
I love it. You guys did so good working together. Thank you for doing that. Okay. I really, hey. I'm probably gonna do this quite a bit in this unit where I'll make you get up and do math standing up. Number 1, you start to fall asleep after lunch. Number 2, I think it's easier to work with people if you are huddled together vertically as opposed to like reaching over the table. Okay. Your homework is page 3. Do your homework. All of page 3. So listen to me though. So I know that some of us